Yes, come to the session, my dear students. Yes, audio and video is clear. So once confirm to me. So audio and video is clear. Audio and video is clear. Confirm to me. Yes. So my name is Lakshmarana. This is Ellen Brand of Chemistry. Today we are going to discuss about states of matter. Then the previous year questions. States of matter, previous year questions we'll discuss. Then before going to the previous year questions, so look at once what are the gas laws are there. For example, if you take Boyle's law, so we know that statement, at constant temperature, the volume of given mass of gas is inversely proportional to its pressure, right? So here, in case if you take, that is, volume of gas is inversely proportional to its its pressure at constant temperature. At constant temperature. So we can also take it as, in case if you take pressure this side, then PV, then proportionality remove, then you can get constant. So based on this, the product of pressure and volume, it is also constant. Product of pressure and volume is constant. Even this is also but Boyle's law only. So product of pressure and volume is constant at constant temperature. At constant temperature. Then one more, see, in case if you take graph to the Boyle's law, so graphical representation, if you observe, graph, the pressure versus volume at constant temperature if you take. At constant temperature if you take, then you can get the curves like this. Pressure versus volume if you take, then we can get a curves like this at constant temperature. Just assume it as this is a T1. Then in case in other temperature if you take, then more than this temperature, then you can get the curve like this. The temperature penchide a curve pine vastund. So then the one more, the temperature, in case if you take T3. So these curves we are calling isotherms. Isotherms. Iso nothing but constant or same, therms, a constant temperature. Isotherms we call. The same graph in case in between the pressure versus 1 by V in case if you take. So we can get a straight line through origin. So pressure versus 1 by V volume if you take. So we can get a curves like this. We can get a curves like this through origin. Then just to take it as T1, then T2, then T3. Then even in this case also, T3 is greater than that of T2, than that of T1. So this must be remembered. The temperature increases. The temperature increases when the pressure increases. Clear all of you? Right? Then one more. So that is graph 3. In case if you take based on pressure volume. So PV versus V. PV versus V. So PV is the constant I told. PV is the constant. Even volume increase అవుతా ఉన్నా కూడా PV అనేది కాన్స్టెంట్ గా ఉంటుంది కాబట్టి so we can get a curve like this. Then or otherwise the PV versus pressure if you take also, then we can get a curve like this. That is, so not curve, straight line through the pressure axis PV then this is the pressure axis ki straight line ila vastundi parallel to the pressure axis. Here parallel to the volume axis you can get. So these are the graphs to the Boyle's law. Just note it based on this what type of questions they are given. So once look at. Then if you take next law, that is Charles law. Charles law, how to discuss. Next one. So we have to take Charles law. Charles law. So what is the Charles law? You know, the volume is directly proportional to absolute temperature. Volume is directly proportional to absolute temperature. Absolute temperature at constant pressure. At constant pressure, volume is directly proportional. So that is actually then V by T, it is equals to constant, will tell. The constant. So graphical representation kanaka chuste. So graph 1 if you take, that is the volume versus temperature, absolute temperature we are taking. So absolute temperature, nothing but the Kelvin temperature here. So here we can get a cause at a constant pressure. The pressure, just to take it as different pressures if you take. Then pressure, just to take it as the P1, then P2, then P3, like this. So these pressures, so look at P3 is less than that of P2, than that of P1. So here volume increases, pressure decreases at this position and at this position and at this position. If you observe, the volume is increasing. So P1 is greater than that of P2, than that of P3. So that's what we are telling. The P3 is very less. Clear all of you? So these pressures we are calling isobars. Isobars. At constant pressure, we are calling isobars. The previous we are discussed about the isotherms. At constant temperature, we are calling isotherms. Then look at the same graph, that is graph 2, volume versus then small t, that is degree Celsius temperature. Here the volume versus absolute temperature, that is the Kelvin temperature. Here degree Celsius temperature. So if you take a graph for this, so volume versus temperature, then here 0 degrees Celsius, then 100 degrees Celsius, then 200, then 300 if we take. Then here this side, the minus 100, then minus 200, then minus 300 if you take. Then we can get minus 273 at 273 Kelvin temperature. 273. At 273 Kelvin temperature, we can get P1, then P2, then P3. So these are the straight line you can get at minus 273 degrees Celsius. So here 0 kelvins, here minus 273 degrees Celsius. So minus 273 degrees Celsius we are calling absolute zero. Absolute zero. Minus 273 degrees Celsius we are calling absolute zero. Absolute zero. So temperature తీసుకుంటే ఇలా వస్తుంది. Clear? These are the graphs for that. Sir, in case third graph if we take, I told that volume by temperature is constant. So graph in between volume by temperature versus temperature if we take. So volume by temperature versus temperature if we take. So volume by temperature is a constant, I told, constant. So we can get a straight line parallel to the temperature axis. Even volume if we take also. Then fourth graph, that is, sir, in case volume divided by temperature versus, then volume if we take volume. So volume divided by temperature versus volume, even if we take also, you can get a curve like this. All these graphs you have to remember for Boyle's law and Charles' law mainly. So based on this, many questions they're asking. So note it, all of you. This is second one, Charles' law. Then next we'll discuss that is Avogadro's law also. So what is the Avogadro's law? Avogadro's law. Volume is directly proportional to number of moles at constant temperature and pressure. Volume is directly proportional to number of moles at STP conditions, standard temperature and pressure conditions. That is Avogadro's law. So look at second one, Avogadro. Third one, Avogadro's law. Avogadro's law. So Avogadro's law in చెప్తా ఉంది, volume is, wait a minute. So volume is directly proportional to number of moles at STP conditions, standard temperature pressure conditions. Volume is directly proportional. Graph if we take, then graph in between volume and number of moles, then we can get a curve like this. Okay, straight line like this, not curve, straight line. We can get a straight line in between the volume and number of moles, right? So based on our combination of all these three gas laws, combination of all three gas laws if we take. So first gas law what we are discussed, that is Boyle's law. We are discussed. What is the Boyle's law? Sir, volume is inversely proportional to its pressure at constant temperature, I told. Second one, Charles' law, volume is directly proportional to absolute temperature at constant pressure, I told. Then third one, Avogadro's law. That is volume is directly proportional to number of moles. At STP conditions, standard temperature pressure conditions. By the combination of all these three, in case if you take, so volume proportionality. Then look at this side, what will be there? So temperature, N number of moles to temperature divided by what will be there? Pressure will be there. Pressure when it is sent this side, then pressure V is directly proportional to number of moles into T. Then if you remove the proportionality constant, PV equals to nRT. Sir, this we call PV equals to nRT is the ideal gas equation. Ideal gas equation. So that is PV Narasimha Rao, it is equals to NTR. PV Narasimha Rao equals to NT Ramarao. So this is what we are calling ideal gas equation. Sir, in the ideal gas equation, capital R is what? Capital R is ideal gas constant or universal gas constant we call. So P, it is equals to pressure. Sir, V, it is equals to volume. Then N equals to number of moles. R equals to temperature. T, it is equals to absolute temperature. Nothing but you have to take in the Kelvin side. Then next one, what will be there? So R, that is universal gas constant. Universal gas constant or ideal gas constant we call. The value of universal gas constant, you can take it as 0.0821 atmospheres, 0.0821 atmospheres, liters, mole inverse, Kelvin inverse. In case pressure is present in the atmospheres, volume is present in the liters. Then one more value is there, that is 8.314 joules, then Kelvin inverse, then mole inverse. Then next one, so 1.98 or approximately 2 also will take, that is calories, mole inverse, that is Kelvin inverse, mole inverse, Kelvin inverse. These are the values actually. So ఇవన్నీ values ని ఎలా ఫైండ్ అవుట్ చేస్తామంటే సరే యాక్చువల్లీ ఐడియల్ గ్యాస్ ఈక్వేషన్ నుంచి R ని ఫైండ్ అవుట్ చేస్తాం. సో ఫర్ 1 mole ఆఫ్ గ్యాస్ at constant temperature and pressure or standard temperature and pressure, STP conditions దగ్గర దీన్ని ఫైండ్ అవుట్ చేస్తాం. సో STP conditions, at STP conditions, standard temperature and pressure. So temperature, if you take 273 Kelvin temperature, then pressure, if you take 1 atmospheric pressure, then from the PV equals to nRT, so in case if you want to find out the ideal gas constant, R equals to pressure PV divided by NT, right? So in case if it is number of moles equals to 1 mole of gas ankondi, then pressure have to take 1, then volume 22.4 liters according to so mole concept. So at STP conditions, 1 mole of gas occupies 22.4 liters, right? 22.4 liters, then 22.4 divided by, so number of moles 1, then temperature 273 Kelvin temperature. If you take, you can get it is 0.0821. Sir, units ఎలా తీసుకున్నాం? Pressure that is present in the atmospheres, then volume in the liters, then number of moles divided by number of moles కాబట్టి mole inverse తీసుకున్నాం, then Kelvin inverse. So mole inverse, then Kelvin inverse, like this. So ఈ values depends upon the pressure and volume values. Pressure and units, pressure, volume, units, the value will be different like this. So joules, calories, atmospheres lo తీసుకున్నప్పుడు. Yes. So based on all these concepts, once look at the previous year questions. Previous year questions చూడొచ్చు మీరు. Previous year questions చూడొచ్చు. So look at the previous year questions one by one. So first from the Boyle's law, based on the Boyle's law onwards. Yeah. Then which among the following graphs correctly represent the Boyle's law? Which among the following graphs correctly represents the Boyle's law? Boyle's law. This is the question number 1. Then this question is given in the 2020 September, the corona time lo September lo exam conduct chesaru. That is September 11th shift 2 lo vachina question ma. Shift 2 lo vachina question. Graphs ila icharu. Graph A sir, pressure versus volume is, then next B is given like this. The pressure versus volume, so exponential curve is given like this. Next one, C, the one more is graph is given like this. Then pressure versus volume, so curve is given exponentially decreases like this. Next D, then pressure versus volume is given like this. So which graph is correct? Actually the all graphs we are discussing, right? So based on the Boyle's law. So this graph, if you observe, sir, Boyle's law is what? Pressure is inversely proportional to volume, or volume is inversely proportional to pressure. So the pressure, if you take the volume, you can get a curve like this. This we call isothermal. So this is the answer for this. So note a question is very important based on Boyle's law. So ఈ క్వశ్చన్ నోట్ చేయండి. నెక్స్ట్ చార్లెస్ లా మీద ఎలాంటి టైప్ ఆఫ్ క్వశ్చన్ ఇచ్చారు. Then one more question based on the Boyle's law graphs. Look at one more question. So look, my dear students, note the question along with me. Which of the following is correct for Boyle's law? Second question. Which of the following is correct for Boyle's law? Like this is given. Yeah, sir, options look at. So this question is given May 6th 2019. May 6th 2019 lo icharu. So that is in the shift 1 question it is. Then graphs, if you look at, pressure versus 1 by D, so you can get a curves like this. We can get a cos like this. Then T1, then T2, then T3. So T1 is greater than T2, then T3, like this is mentioned. Then second graph, observe the graphs carefully. ఎలా ఇచ్చారు గ్రాఫ్స్ అనేది అబ్జర్వ్ చేయండి. సో ప్రెజర్ వర్సెస్ వాల్యూమ్ ఇచ్చారు. సార్ కర్వ్స్ ఇచ్చారు T1, T2, T3. T1, T2, T3 ఇచ్చారు. సో T3 is greater than T2 than T1 ఇలా మెన్షన్ చేశారు. నెక్స్ట్ B, that is graph in between product of PV versus P. Then they are mentioned here T1, T2, T3, T1, T2, T3, T1, T2, T3 ఇలా మెన్షన్ చేశారు. So even here in this case T3 is greater than T2 then T1. Next fourth graph. So observe the graphs carefully, note down the graphs carefully. Yes, then PV versus P. Then again temperature, different temperatures T1, then T2, then T3 is mentioned. So T3 is less than that of T2, then less than that of T3, T1 ఇలా ఇచ్చారు graphs. Yes, observe the graphs carefully. Actually these are not options. So options ఇచ్చారు. So that is A 4 only. The B is given 2 and 4. Then C is given 1 and 4. Then D is given, that is 2 and 3. ఇలా ఇచ్చారు graphs. So observe carefully. The temperature, when pressure increases, temperature increases actually. So in this case, if you observe, set at this position of pressure, then T1, then T2, then T3 if you observe. So temperature increases nothing but T3 is greater than T2, then T1. So the pressure volume graph always curves. These curves we are calling isotherms. We are already discussed. Yes, B is correct answer. Yes. So B nothing but these are actually 1, then 2, then 3, then 4. 4 like this is mentioned. Clear? Then even if you take pressure 1 by T density, this graph is there for the Boyle's law? No, not there, right? So for this pressure volume, product of pressure volume versus pressure is there. So we can get a straight line through the straight line parallel to the pressure axis, right? Yes. Even here also parallel to the pressure axis. Then here parallel to the pressure axis. Yes, right. Both graphs are same, but here you have to observe one of the thing, that is T3 is greater than T2 than T1. So this is 3 is correct answer. So 2 and 3 are the correct answers. So D option is correct answer. Clear all of you? So why it is wrong, man? So because T3 is less than that of T2, then T1 they are mentioned. So actually T3 is greater in the Boyle's law. Yes, look, my dear students, next question we'll discuss. Next question. Based on the Charles law, again, based on the graph, what type of questions they're asking? What type of questions they're asking based on the graphs? So look at once. Look at once. Right. A plot of volume. That is question number 3. Of volume versus, so volume of the gas versus volume of the gas versus temperature, that is in the kelvins, is shown below. Which of the following options is correct for the plot? Which of the following options? Which of the following options? Which of the following options correct? Which of the following options correct for the plot? Clear? This question is given in the 2021 August 4th జరిగిన exam. Then shift 1 లో అడిగిన question. Clear? So here one of the graph is given. The graph is 273 at 0. The kelvins only is mentioned in this case. The temperature is given. The pressure. Right. So volume versus temperature. Then here mentioned P1, then P2, P2, P3. Yes, observe carefully. Then options are option A, that is P1 is less than that of P2, then that of P3. Then B, then P3 is less than that of P2, than that of P1. Then C, then P1 equals to P2 not equals to P3. Then D, that is P1 equals to P2 equals to P3 equals to 0 at 273 Kelvin temperature. Like this is mentioned. Kelvin, like this is mentioned. So which graph is, which is correct? Which option is correct in this? A option correct avutundi. So actually the graph is correct for the Charles law, right? So actually ide graph manam ikkada normal T తీసుకుని డిగ్రీ సెల్సియస్ లో రిప్రజెంట్ చేశాం. సో డిగ్రీ సెల్సియస్ లో రిప్రజెంట్ చేస్తే ఇది 0, ఇక్కడ యాక్చువల్ గా 0 అని మెన్షన్ చేశారు. సార్ 0 at 0 degree Celsius, at 0 kelvins, not Celsius, the kelvins is there, at 0 kelvins it is equals to minus 273 degrees Celsius అవుతుంది. ఈ జీరోనే మనం అబ్సల్యూట్ జీరో అంటాం. అబ్సల్యూట్ జీరో దగ్గర ఆల్మోస్ట్ ఆల్ ది గ్యాసెస్ క్యాన్ బి కన్వర్టెడ్ ఇంటూ లిక్విడ్స్. Clear? Can be converted into solids. Clear, all of you, right? So look at, so ikkada pressure ni ganaka manam observe cheste, pressure volume, so ikkada volume increases, pressure decreases, right? So P1 is less than that of P2 than that of P3. Once again listen carefully, once again. So volume increase chesta velte pressure decrease avutundi kabatti P1 takku untundi, dan tarvata P2, dan tarvata P3. So P1 is less than that of P2 than that of P3. So this is the correct option for this. Clear? Understand all of you? Yes. So note down the question and answer. Note down the question and answer. Next, come to the another question that is based on Graham's law. Yes. So based on the Graham's law, they are given one of the question, that is the ratio of rates of diffusion of oxygen. The question number 4, the ratio of rates of diffusion of gas, diffusion of oxygen, diffusion of oxygen and an unknown gases, unknown gases 1:4. The unknown gases, the unknown gas is, they're mentioned like this. So options ichadu, SO2, then B nitrogen N2, then C H2, then D, then mentioned the D2, nothing but deuterium gas, D2, they're mentioned like this. So observe the question carefully. This is based on the Graham's law, I told. So what is the Graham's law, man? So Graham's law enti, the rate of diffusion of any gas is inversely proportional to square root of its density, or rate of diffusion of any gas is inversely proportional to square root of its molar mass, right? So our rate of diffusion of any gas is proportional to 1 by square root of its vapor density also you can take. So inversely proportional to square root of density, inversely proportional to square root of molar mass, inversely proportional to square root of vapor density. Anyway, so here we have to take, so based on the molar mass we have to take. So molar mass ni base cheskuni manam find out cheyochu. So how? The rate of diffusion of, ratio of rate of diffusion is given. So that is, in case if you take R1 divided by R2, it is equals to square root of M2 divided by M1. So R1, so rate of oxygen ankundi, R1, that is 1, you have to take it as O2. Then this is unknown, clear? Then M2 you have to take unknown. Then this is molar mass of oxygen, right? So the ratio is given 1:4. Then 1 divided by 4 equals to square root of, sir, molar mass of unknown gases divided by molar mass of O2, how much? Sir, oxygen 32, 16 plus 16, 32. Clear? So if you take square root both sides like this, square, then square, so square root cancel, then square, so we cannot square. So 1 by 4 just 16, 1 by 16, it is equals to, so molar mass of unknown gas divided by 32. So manaki em kavali dintlo, molar mass of unknown gas, it is equals to 32 netwaipu panchandi, 32 divided by 16, 32 divided by 16, 16 1 ja 16 2 ja, so you can get 2, the molar mass 2 for hydrogen gas. This is the answer. Clear, my dear students? Yes, note down the question. We'll discuss one more. Yes, next question. So this question actually they are given in the 2021 August 4th. The 2021 August 4th lo vachina question idi. Yes. Next question we'll discuss. Which of the gas has the density of 1.24? Yes, my dear students, observe the questions carefully. So what we are discussing, the question number 6, look at. So share my channel, subscribe my channel, like, then say to your friends, those are preparing for the EAPCET, nothing but EAPCET Telangana Andhra. Better to share, those are poor students will be there. Those cannot take either short-term coaching or long-term coaching. Those are preparing in the home. So better to share my videos to them. So better to subscribe or tell them to subscribe my channel. Clear? Yes. Which gas has come to the question, a density of 1.2 gram per liter at 0 degrees Celsius and 1 atmospheric pressure. 1 atmospheric pressure. 1 atmospheric pressure. So options ichadu, that is fluorine gas, B methane gas, C CO carbon monoxide, D carbon dioxide is given. This is given in the August 5th, then 2021, then shift 1 lo vachina question idi. Sir, here density, relation between the density and molar mass meeda ee question undi. Sir, actually density relation between the molar mass meeda question ela vachindi, ela relation vachindi ante, sir, actually this is PM equals to DRT ila vachindi. Sir, density kavali ante P into molar mass divided by RT. Density ichchadu kabatti molar mass kavalante molar mass equals to DRT divided by P ila తీసుకుంటాం. సో ఈ రిలేషన్ ఎక్కడి నుంచి వచ్చింది అంటే the relation is came from again PV equals to nRT. Sir, n nothing but what? Number of moles. So number of moles ante that is equals to molar mass, number of moles, given weight divided by molecular weight, so given weight divided by molecular weight, right? So PV, it is equals to, so given weight divided by molecular weight into R into T. So molar mass ఇటువైపు సెండ్ చేయండి, వాల్యూమ్ ఇటువైపు సెండ్ చేయండి. PM equals to then given weight divided by volume into RT. So density nothing but volume divided by, so weight divided by volume, right? Given weight divided by volume, grams per liter, weight divided by volume. So PM, it is equals to DRT. ఇది ఫార్ములా యాక్చువల్. ఈ ఫార్ములాని బేస్ చేసుకునే మనం మోలార్ మాస్ ను ఫైండ్ అవుట్ చేయొచ్చు. మోలార్ మాస్ ఈక్వల్స్ టు DRT divided by pressure. This is the formula. సో ఇందులో మోలార్ మాస్ ఫైండ్ అవుట్ చేయాలంటే డెన్సిటీ ఎంత ఇచ్చాడు? 1.2. దెన్ సార్ అట్మాస్ఫియర్ లో ప్రెషర్ ఉంది కాబట్టి R వాల్యూ యూ హ్యావ్ టు టేక్ ఇట్ as 0.0821. Then temperature, they are mentioned the temperature 0 degrees Celsius, that you have to convert into the Kelvins, man. So absolute temperature you have to take, that is 273. Then divided by pressure, only 1 atmosphere, right? 1 atmosphere. Then 1.2 into that 0.0821 into 273 in case if you take, that is 22.4 you can get. 22.4 into 1.2 in case if you get, so nearly 28 molar mass, you can get the 28 gram mole inverse. So 28 molar mass, this is the molar mass for 28. So carbon monoxide is the correct answer for this. Clear all of you? Right? So next, one more question, look at. So all these videos are recorded, all these videos are uploaded in the YouTube itself. So you can search later in my channel. Sir, in the live sessions you can search. Sir, in case if you don't have time, so those are going for the coaching. Sir, you can later also see my videos all. Yes, come to the next question. The RMS velocity of question number 7, right? The RMS velocity of dihydrogen is square root of 7 times more than that of dinitrogen. If TH2 and TN2 are the temperatures of dihydrogen and dinitrogen, then the correct relationship between them, relationship between them this is the question is given. So 2025 May 2nd lo adigina question. May 2nd shift 1 lo adigina question. So options ila ichchadu. Option A, TH2, it is equals to TN2. Then option B, TH2 is greater than TN2. Then option C, TH2 it is equals to square root of 7 into TN2. Then option D, then TH2 is equals to then TH2 divided by 2. So this is given like this. Look at the question carefully. Observe the question. RMS velocity formula 3RT divided by capital M. So RMS velocity it is equals to square root of 3RT divided by molar mass. This is the formula. Then RMS velocity of dihydrogen is then square root of 7 times more than that of dinitrogen. So ikkada the velocity, that is RMS velocity of dihydrogen, that is equals to then square root of 7 times of the RMS velocity of dinitrogen is given, right? Clear? So RMS velocity of hydrogen we can take, that is square root of formula you can use 3RT. It is hydrogen, then molar mass it is equals to, so square root of 7 into, then for this, so 3RT, then into dinitrogen, then molar mass like this. Then here we can remove the square root of square root of 3r, then square root of 3r both sides. Then TH2 divided by molar mass of hydrogen is 2. So TH2 divided by 2 equals to, then if you remove the square root, 3RT, then 7 1s is 7. Say the molar mass is how much, man? Molar mass of nitrogen is 28, right? So 28, 7 4s, it will go. So we can take it as, if you remove the square root both sides, square root 3RT and 3RT both sides, then you can take it as, so Tn2 divided by 4, right? Tn2 divided by 4. So here, once, then 2's. From this, you can take TH2, it is equals to Tn2 divided by 2. Clear? This is the relation between them. So TH2, it is equals to, Tn2 divided by 2. This is the answer. Clear? Understand all of you? Yes, note down the question carefully. Yes, the remaining questions, whatever the questions will be there, that we'll discuss today evening. So please subscribe my channel, then share my channel. Thank you.